Hello, everyone, and welcome back. How is HashiConf treating everybody on day one? Great. It appears to be treating everybody with applause. Very excited to introduce the first of our two closing keynotes for day one. I'm super excited to welcome two speakers, Dan and JP. Dan is a senior web developer at Mozilla. Although, if you ask him for a business card, he's worked incredibly hard to make sure that his official title at Mozilla is Sparkly DevOps Princess. JP is a DevOps Internet Jedi. He joins Mozilla Corporate, previously from the Mozilla Foundation. And prior to that, he was one of the 4 DevOps engineers who worked on the 2012 Obama tech campaign. Please join me in welcoming them to the stage.
Thanks, buddy. Hello. Ooh, hi.
Hi, everybody. I'm JP. This is my colleague, Frosty.
What's going on?
So, hey, we're here to talk to you a little bit today about what we did to move a gigantic application using all of the HashiStack that we've been talking about all week. It was a really easy thing. Went off without a hitch.
It'll take about really 5 minutes to explain. Don't worry about it. It's fine. So as you can see, I'm a classy guy. And classy guys open presentations with Shakespeare.
Obviously.
Here we go. 2 data centers, both alike in dignity, in fair Mozilla where we lay our scene. From ancient standards, break to new paradigm, where civil syntax makes civil code unclean. From forth the Git repos of these 2 foes, a trio of star-crossed DevOps engineers make their life, whose misadventured, piteous overthrows do with their commits bury their manager's strife. The fearful passage of their markdown docs and the continuous deployment of their apps is now the 40 minutes traffic of our stage.
Hopefully. Hopefully.
No, in all seriousness, we're going to talk about that time we took our entire physical stack and put it in the cloud. Okay, seriously, JP, for real, what are we talking about?
Well, I mean, obviously, we're all here to talk about technology. Nobody here really works on farming beets or anything like that.
Speak for yourself.
Well, I mean, most of us don't make our living off that. We're here to talk about humans, though, right? Most of our job has to do not just dealing with technology, but dealing with the crossroads of where that technology and where human beings, flawed, dangerous, unpredictable, where those intersect.
Exactly.
So we've got a lot of deep dive, but we're not going to put it up on slides and talk to you about code examples. We'll save that for a link afterwards.
What we are going to talk about, for a little bit at least, is this. Something called SOCORRO. It's crash stats.
So what crash stats is, anytime Firefox crashes, probably because of Flash, we are sorry. We're sorry, we don't want it to crash. But when it does crash, a little icon pops up right after you're using Flash that says, do you want to report this crash? And when you say yes, first of all, thank you. We need that data. We want that data. We don't want you to keep crashing.
It doesn't disappear into the ether. We do use that data. Those crash reports are important.
And so as we think about it, let's think about the scale of that. How many of you guys have Firefox installed?
Oh, thank God.
Yeah, good job, good job.
Thank you.
Notice I didn't ask how many were using it primarily.
Give away our secrets.
But think about that, right? There are hundreds of millions of installs of crash stats throughout the world. So we're not just moving a little Django app or a little WordPress app, are we, Frosty? We're moving kind of a big app.
Well, let's talk about that actually for a second. How about a brief history of everything?
All right.
All right, the entire stack that deals with those crash reports called SOCORRO. It's a code name. It's open source. Ooh, echo. Should I step back? Is that better? All right. It's open source, as everything is open source, right? Don't worry about this link. We're actually going to put up a link that's got everything at the end, so don't worry about it. It's basically a bunch of Python applications and some databases we found lying around on the internet. So it should be fairly safe. It's 12-factor-esque.
So 12-factor, let's talk about that for a second. Can I see another show of hands? How many people know what 12-factor app is? Okay,
Splendid.
so for any of the hands that were down, which there weren't that many,
Which is good.
12factor.net is a great write-up done by the amazing folks at Heroku, where they basically describe how an application can become modular, scalable, safe for the cloud environment. And so we're not going to go into each of the 12 things that makes that, but if you haven't read it, go take a look at 12factor.net. Using Heroku as the example, if you can get your developers to go run their app on Heroku, that's essentially a gateway to say, is your app 12-factored? And if it's 12-factored, our jobs are going to be a lot easier, we're going to get a lot more sleep, and that's why we're all here, right?
So speaking about those databases we found lying around on the internet, back in the day, there were a lot of moving parts. This is a simplified diagram, in fact, of SOCORRO. You can see we've got a web browser and a crash reporter and some collectors, and we've got we get some HBase in there for some reason, some POSTGRES, FTP. We have an FTP scraper, that's a lot of fun. An automatic emailer, LDAP.
This looks great, yeah, this looks great.
God.
Let's do this right now.
Let's do this, this is amazing. Well, this isn't a talk about SOCORRO, right? We're just trying to establish the scope here of the project.
And here's where we started, right? I mean, this is, as we walked in and said, we need to make this 12-factored, or at least 12-factor-esque. We need to put this into a scalable, modular, service-oriented application type of setup.
Yeah, and with this many moving parts, the simple fact of the matter is that failure has to be an option.
Oh, it's absolutely an option.
Has to be an option, because things are going to fail, right? So that means functionally that all the elements in the equation that we can control, so the code that we've produced, has to be resilient to service degradation or failure. So buffering, spooling, caching, failing gracefully, or in predictable ways.
Now, and as we talk about this, right, a lot of people might see our jobs as preventing all failures, right? How many people want to prevent all failures? I mean, if you're not raising your hand, you're lying. That's crazy.
No, you can't do that.
What are you thinking? But, of course, we're never going to prevent all failures.
Right.
Our real job is to make failure not hurt for long, and hurt in a very visible way that both we and the developers know about.
So I'd like to say that this design decision was because we're really good programmers who design good software, which is true. But really, it's because we had 99 problems and HBase was most of them. So in fact, actually, we switched to CEPH briefly.
How'd that go?
I actually have a very short story to tell you about CEPH.
Let's see if there's...
This is our very short story about CEPH.
It's fine, it's fine.
Fire,
it's going to prod. It's
and,
good.
then we bailed out. That's our
At least
short
we got out.
story about CEPH. So at one point in the not too distant past, we received a warning of an incoming apocalypse. The end is nigh. Turns out the vast majority of our infrastructure was located at a single data center. Yep. And that data center was going to disappear.
Yeah, real soon too. I mean, in the context of things, right? Moving an app in a couple months versus a year.
Right.
So this was a couple months.
Yeah, it was a couple months, right? And so it's sort of the thing, like, right, stay at the end of the night at the bar. I don't care where you go, but you can't stay here. But yeah, but don't we have it at data centers? They're full of other things that we're moving from the one that you're losing. Wait, what? Okay. So wait a minute.
So we have a
It's going to be the end of the world?
really hard deadline.
Right. What do you do? What do you do when it's going to be the end of the world?
Well, you probably need a new world, right?
Yep.
So this has absolutely nothing to do with Star Trek.
Nothing.
If there's anybody thinking about intellectual property, this is just something
Fair
we found
use.
on the internet.
Fair use.
And so we've been looking at what all these developers, all these neat things they've been doing over the last decade, over the last 5 years, over the last 2 years, where they're getting all of this continuous delivery for their code, and we're thinking, I want that too.
I want continuous delivery.
I'd like that, yeah.
Continuous delivery sounds great. How can I, as a system administrator, also get continuous delivery? Well, the thing about continuous delivery is that it's kind of scary.
Well, it can be
Right?
super scary, especially as you're looking at it and you're saying, hey, you know what, like making a lot of changes fast is inherently riskier than making no changes, right? Except our job is to make changes. It's literally our job. And so we're going to have to. And so even though in the short term it feels scary because we haven't done this before, we're putting things in the hands of other people who maybe haven't done this for their whole life like we have, that can look really scary.
It's true. Now it's time for some brutal honesty, all right? Continuous deployment hasn't seen particularly widespread adoption within Mozilla. Okay, that's a fact, and I want to get that out there. We work in the public. But we're moving in that direction. And these are the sorts of projects that enable us to move in that direction. These sort of scorched earth policy projects where we get to sort of scrap everything and be like, look, whatever we're doing before, it doesn't matter.
And in fact, you know, we're not really talking about how we did this for the particular project I'm about to mention, but you guys mentioned earlier, you know about Firefox. We're about to start delivering certain parts of Firefox and eventually all of Firefox as continuous delivery.
Continuous delivery to your computer.
Now it can feel scary.
Who here has had to orchestrate changes on 100 nodes? 100 nodes.
I'm sorry about that. That
1,000 nodes? 10,000 nodes? How about 850 million nodes?
Right.
So continuous delivery. It's kind of scary, and it comes down to, in my opinion, at the very least, why it's scary is a lack of trust.
Right, and that lack of trust has been a lack of trust between operations, development, product management, and historically, you know, what we've seen is a giant divide between those.
It's true. It's absolutely true. One of the things that I really like about continuous delivery, though, and this is the last point I want to make before we move to the next slide, is that it allows you to catch bugs a little faster. And the reason I want to say that is I have a great quote from our esteemed colleague, Mr. Rob Helmer, which is that bugs are more expensive the further out in the process you are, right? It's really cheap if a developer catches a bug in their own code, right? That's fast. If the reviewer catches it in PR, it's a little bit more expensive, but
we thank the reviewer.
Exactly. If the bug is discovered in stage, again, that's more expensive, but at least it didn't make it to prod. Maybe you caught it in prod and it actually cost you money, and that sucks, right? Or maybe the bug is discovered when everything is on fire and the rule of law is a blissful memory and we're all single combat in a Mad Max-style Thunderdome. That's more expensive.
And that seems how it often was
right?
back
And then,
in
of
the
course,
day,
the stage
wasn't it?
after that is that the bug is a feature and now you can't get rid of it. So that's going to cost you. So yeah, a lack of trust. How do we solve this problem?
Well, let's first talk about, you went the wrong way.
Ooh, I can go the wrong way?
So let's talk about the stack, right? We're talking about the HashiStack, or maybe you're using Go. The real important thing, though, that really drives either success or just horrible abject failure in our organizations is the human stack. Now, we had this old bust human stack. It was great for a while, right? It was great until it wasn't great. And that lack of trust really was derived from the fact that developers, they couldn't see any data. But was it that we weren't giving them data because we didn't trust them? It's kind of a non-virtuous cycle, isn't it?
Unvirtuous cycle?
Non-virtuous, unvirtuous. I'm not sure either. We'll have to get feedback from the crowd.
Yes. So speaking of feedback, the problem was there was no feedback loop.
Right, exactly. And thus, no real accountability. If I'm a developer and I push the worst code I've ever pushed, well, I just file a Bugzilla ticket, right? That's how we're interacting. That's how we push to prod. Yeah, sorry about Bugzilla for anyone who's using it. We have a great opportunity with that app to move it forward.
We sure do. That's an opportunity.
And so the way that we move this forward is to bring that trust back into our teams, to trust the product managers, to trust the developers, and for us to just be able to sleep a lot more.
That's it.
We have that strong feedback loop.
So we built the new hotness, this new human stack, right, where trust is inherent in the system. It's developer-driven. That's a key thing, right? It's like we got to try to take ops people out of the picture a little bit, not because I don't like doing my job, but just because I want to do a different job. Right?
Because I want to go to sleep.
Yeah, fair enough. And I guess you have a strong feedback loop into it. Now this is the point where I want to say, wait a minute, Frosty, you're thinking this is HashiConf. Are you going to talk about Hashi tools?
We'll talk about this.
Yeah, we're getting to there. All right, we're getting there. But you see, it's all background, right? So how do we get the human stack? In fact, the HashiStack, if you will, allowed us to get here. This was a pipe dream. We didn't know how we were going to get there.
And we only had a couple months.
We only had a couple months to do it. brief foray. Storage, something, I don't know what S3 stands for. I mentioned earlier that we had...
But it's definitely 3 S's.
It's 3 S's. Yes. We had problems with HBase. And as you know about Ceph, that didn't work out well. So we had to figure out a place where we could put all of this data. There's tons and tons of terabytes of it. We thought, well, we'll just put it on S3, and then we'll think about what we're going to do with the rest of the stack later. Because we weren't sold necessarily on Amazon or like anything yet. But since we already had some operational experience with AWS, we thought, well, wait a minute, what happens if we move everything to AWS? Can we do that? Can we move an entire like data center worth of stuff?
Well, it seems like pretty much all of the stack should be able to be really easy to move.
Sure,
well,
yeah, everything's
except
suddenly
maybe,
PostGRES.
Oh no.
Oh my God. We were pretty comfortable, you know, with running everything except this. So our esteemed colleague, Selena, our in-house Postgres specialist, prototyped running Postgres in Heroku. It worked fairly well. She did a good job on it.
But now we're using Heroku and AWS and maybe some
now I think,
legacy stack.
Yeah, and then we want to use the Google thing too to do the compute.
I would like to do that.
I'd like to do some of the compute. Yeah. So now we have multiple cloud infrastructures, totally different APIs, configuration systems, you know, management strategies. You know what would be amazing, JP?
I mean, I don't really want to write multiple things, right?
If there was some sort of multi-platform, I don't know, cloud infrastructure management tool.
I don't know if there's anything like that.
Is there?
Oh! Now, apologies. We didn't have time to add all the extra icons you guys added today.
Early on in the project, I literally said to my manager, I get the feeling that we're going to just end up using Hashicorp's tools for everything. And I got laughed at. Mm-hmm. Who's laughing now, Lonan?
I don't know where you are, but...
Who's laughing now? So what this got us was that dream of sort of multi-cloud, multi-platform, how do we get a data center worth of stuff into the cloud through a single uniface? But wait, there's more!
And so this is after years, right? I came through the Obama campaign. It's years I've been hosting stuff on AWS before I made it over to their team in April. But I still didn't have any of this cool stuff.
Right. So this is some of the neat stuff now that we were getting with just even Terraform, right?
So we had talked a little bit earlier about how these developers, they have all this really cool continuous delivery stuff, and it's working out really well for them. And some of the ways that they're doing it are all these other ways that we haven't been doing anything like on the infrastructure side of things.
It's kind of hard to like version control hardware, right?
Yeah, and configuration.
Yeah, it's kind of weird. And I guess you get a Puppet, you put it in a Git, but then what's all the stuff that's not in Puppet?
Can I see a show of hands for how many people have used CloudFormation?
CloudFormation?
And how many of you wound up having to check into the psych ward for any more than 3 days because of that?
JSON-related mental anguish. Oh, God. I still get the tics. It's not good.
Right, yeah. Looking at that, like, hurts my heart a little bit.
Right. So immediately what we got, just in saying, OK, let's try out Terraform, and it was still kind of a primitive tool at this time, we immediately got version control for our infrastructure, right? We immediately got peer review. We were able to just use GitHub to like look at infrastructure changes, which we'd never been able to do before, and that was freaking amazing. We had an audit trail, right? And of course, the aforementioned JSON-related mental anguish. We're not going to go into the technical details of all this. Everybody here uses these tools. It's fine.
And all of this is, again, we're going to have a link at the end when you say, like, hey, let's take a look at the code Mozilla wrote.
Our
cool,
entire infrastructure
we'll go
is
there.
open source.
We just
so
don't want to put you to sleep right now.
So what did this end up looking like? It looked a little like this.
We talked about it, Frosty, being developer-driven. And so as you can see here, we've only got good developers working on the SOCORRO project, luckily. And so the real challenge for us was there was this hard requirement that Lonan gave us, our boss, saying, I don't want developers to have to do anything except for touch GitHub, touch the same git push commands that they're already used to. And so you see here, this is our most popular slide that people like to take pictures of. Feel free to take a picture. We'll leave it up here for another second or two.
Most popular slide. That's bold.
Yes. Well, I mean, they haven't seen the...
What in here is not super important.
slide.
The biggest thing to note is that the devs just interact with GitHub, and that's it.
Right.
Everything else just happens in the background. It's super
abstract
nice,
to
and it
them.
works fairly well, right? But the thing about this is in a perfect world.
Well, that can be scary, right, Frosty?
Well, yeah, it can be scary, exactly. And in a
How do
perfect
you
world, it works
prevent
great.
that?
But we live, unfortunately, in an imperfect world.
We do.
We do. It's sad,
Sadly.
but it's true. So we can't
Thanks,
rely.
Obama.
Thanks, Obama. So we can't rely on this working all the time. You got to watch it.
We have to watch it. But the thing
Watch
is, you have to watch it from multiple angles, right? If we put all of our monitoring into any one of these things, and any one of those things goes down, we're completely hosed.
Super screwed.
So what we did instead is we have 3 different ways that we're monitoring things. And they're each looking at something that other pieces are also kind of looking at. We've got Datadog, who's kind of saying, okay.
Datadog?
Datadog? Datadog? I'm not sure. Again, we'll have to go to feedback from the crowd. But that's essentially saying how many crashes are you moving. You could tie any type of stats D data in there, as well as all of this really great events data that I'm going to show you. It's
like
really great.
Twitter for metrics. It's awesome.
And so then we've got CloudWatch kind of watching some of those same statistics. Is the CPU of our RDS instance, is that doing okay?
Yeah.
But it's also watching, is crashstats.mozilla.org up?
That's a good question.
And then we've got Pingdom also watching that. Now, see, the thing is I tend to use New Relic quite a bit. Any of the talks I give, if you've ever seen me talk, has been mostly about New Relic. Datadog just happens to be what we're using for this project. New Relic, we still love you.
War.
We're not breaking up with you.
That's not that important, right? Everybody's using monitoring tools. The point is that you definitely do need to be monitoring. You want to diversify your monitoring tools. If one goes down, you don't want to not have visibility. So really the question is why? Why are we having to implement all of this overhead in monitoring tools and pay all these companies all this money? And the biggest thing is getting context, right? Getting the right data at the right time to the right people in the right situation, right? And with this, again, this pipe dream, this thing we were building, this magical unicorn system that was going to be awesome, we wanted to make sure that everybody could get access to the data that was pertinent to them.
And by everybody, we mean not just me, not just Frosty, not just Lannon, but also the product managers, right? So this new feature they released.
QA people.
How's that going?
Right?
QA people need to see that.
Everybody needs to be able to see what's going on, but not everybody wants to parse raw logs. Right? So you give people
which is weird, I don't understand that. But.
I love raw log. Whatever. So knowing how things broke is good, right? Nagios will tell you that. Nagios is going to tell you when something's broken. That's fine, that's good. Knowing how things worked, that's interesting, right? When you make a little change and everything keeps working, what did that little change do?
Well, the only way that we can really do that, though, is using visible ops. So this is an animated GIF. We're going to let this play for a couple seconds. But what we see here is me using Datadog. I told you about the event stream. The thing we most commonly ask as DevOps people when something breaks, right? Who did what? All right, who was messing around on our system?
No such thing as a blameless postmortem. It doesn't exist.
And so we see down here, oh, there's that giant error spike. What the heck was going on right here? So up here, we're able to take the event stream that you can pipe into Datadog. You're able to send anything from CloudTrail logs to what was happening in Jenkins. You're able to send all of that up to Datadog. So when you're looking at these performance metrics, let's find out what was happening on Jenkins at the same time.
Yeah.
So were there any pushes? In fact, there were. Over here, we see all the red lines associated with when we made changes in Jenkins.
Right.
And so that tells me what changed and why are you complaining?
Right on. So that's what's perfect. Why are you complaining? It's true. All of this again, right? We're kind of just this. Always be asking why. Why are we doing this? Why are we doing that? And the answer is, it's sciencey. Right?
Scientific method, right?
It's sciencey. So for those of us who have been out of school maybe for a little while, the scientific method, quick refresher. Ask a question, make a hypothesis, test the hypothesis, analyze the results. Make a conclusion, communicate the results of your conclusion, rinse, repeat, right? Scientific method.
So essentially, if you know how you're doing right now, because you're measuring it, you know what you changed when. You saw that last slide we had that was animated and showing you all of the event stream, and you know how you're doing right afterwards, you can tell, did that change help or hurt?
Or hinder.
Were we wrong? Were we right?
Now, a really important thing about the scientific method, and we're actually going to come back to this, is that it's important to conduct a fair test, right? Where you only change one variable, you leave the rest the same.
Well, that sounds like continuous delivery, Frosty.
Like, have you immutable something?
Oh.
Huh, interesting. So you only change one variable, test, change one variable, test, right? So when we were thinking about can we be sciencey? Can we be sciencey with our approach?
Yeah, we want the same cool things developers have now.
Right, propose a change, commit some code. We can do that, right?
Yeah.
Run some tests.
Well, I mean,
tests.
Can we do that? How would we wind up doing that?
How would we do that? How would we do this? We would use the HASHISTACK. We use Packer and Terraform and CONSUL and Atlas and a little bit of Vagrant on the side. We don't use the other things yet, although I think Vault would be pretty cool.
Well, Vault is really our probably next thing we're going to implement. That's kind of a little bit of console and Hera right now.
We're using it, but maybe just not like the whole way.
Console for us right now is a key value store to say, here's my configuration.
Yeah.
But secrets we're keeping in Hera.
Yeah, exactly.
Just because we haven't had a chance to update to Vault yet.
Mm-hmm. Atlas was a bit of a later addition, but actually there's a really good white paper that, has it been released? I guess it must have been released. It's a Mozilla white paper on the HashiStack. You read all about how we did Atlas and everything. It's really cool. Check it out. It's got our pictures in it.
Sorry about that.
So let's walk through that a little bit. What do we use Packer for? We use Packer to build a base AMI. It's capable of running any element of the crash stat system. It includes SOCORRO itself, so the actual code base, right?
So when
Libraries,
we say
support services, databases, friggin' like whatever.
Right, Elasticsearch, any node can run Elasticsearch or the web app.
Anything.
It's not really 12-factored.
It's not really 12-factor, but
we're pretending it is.
We're pretending. Now we do use the base AMI model. This model is not universally accepted.
And it's not necessarily compatible with the current versions of HashiStack. We're looking towards that. We're working with everybody there. But essentially, there's a kind of an advantage, I see, to using the same AMI in staging, right? So we use Packer. We make that AMI Frosty.
Yeah.
And that's what's going to go to staging.
And we make that AMI so hard.
Oh, yeah. And then we push it out to staging. And we're like, holy heck, this is awesome. Let's push this to production.
Yes.
The same AMI, which is an artifact. Let's consider the AMI an artifact that you need to test. I personally like testing that in staging and then having the same AMI created go to production. And the way that we kind of do that, obviously there's going to be configuration differences. You don't want your staging server talking to your production database. We're using CONSUL for that. And we have
we'll get to that a little bit, though, I think.
We do. But just to make sure that there's no confusion.
The biggest takeaway is that we're using literally the same AMI in our stage and prod. We don't rebuild it for prod. We just think this helps us to guarantee that, the atomicity of having only one thing that changes per test and so on and so forth.
Again, scientific method, right?
Scientific method.
Yeah.
What do we do after we've built the base AMI? We Devops is what we do.
Yes, we do.
So we use masterless Puppet. You could use anything you wanted to
and in fact,
provision the node.
A lot of that can be done using remote execs inside of Terraform.
It's true. So the base AMI is used to provision roles, which are basically just configured AMIs that do a thing. We pass a bunch of things to the newly instantiated nodes via user data. Now, concerning user data, we basically have a wanton disregard for all that is good and true. So we do a bunch of terrible things. We've got awk, we've got sed, we've got bash, we've got
There's nothing wrong with bash, Mr. Frosty.
What's really cool about being a modern day system administrator is all of the shiny new tools we get to use that we haven't been using for the past 20 years.
Because bash is just fine.
I really like that about being DevOps now, is that we don't have to write bash anymore.
So user data is really the thing that changes between our environments.
This is all, by the way, open source in case you want to look at it.
And the link at the end will have links to all of this.
So now we've got a thing. We can deploy stuff. There's still a lot of moving parts.
So as we had talked about those 12-factored apps, what you see up here, each of these little sets of nodes is a completely different auto-scaling group, different load balancer, right? Now, it's the same AMI being pushed to each of those. But what we chose to do, even though because of our time frame and our hard deadline, we weren't able to make everything 12-factored.
That's okay.
We architected our Terraform infrastructure, and thus AWS infrastructure and Heroku infrastructure, to be as if it was 12-factored, so that as we get to a point where we have developers split out these apps, what we're able to do is take those apps and just change which repo each of these different groups of clusters are pointing to.
Works out pretty nice. So you say it's not perfect, but you don't want to let perfect be the enemy of the good, right? Like get something that works, get something that people are happy with, make it modular, get it out there. Once it's modular, you can iterate over it, right? So boom, no problem. We're talking a little bit about console, right? So let's introduce the slide about console.
Do we have a, okay. We have a slide about console.
We do use console, as JP mentioned, to populate configuration data. So we're not using it for service discovery yet, although I think it's kind of interesting.
As we move forward and we're looking at build packs.
But this applies into our whole idea of deploying the same AMI and provisioning roles to do different things, right? So we want to reduce the number of things that change and only change what needs to be changed. And so we distribute this configuration information to our nodes once they're running with console. All of our apps run via env console, which is another cool little
It's great utility, thank you.
Yeah. So does anybody else here use env console? I get the feeling it's not as popular. Yeah.
I saw a hand. No, that was two hands.
All right, so maybe it's worth actually talking about what env console is.
Sure, so let's say I was going to run an Nginx process, right? I might just do like a sudo service restart Nginx. Instead of doing it like that, our applications get started. It's a lot like if you're familiar with the tool Foreman, where Foreman's able to take anything you have in the environment. Let's say you just do a command line, my variable equals JP has no idea what he's doing, and you wanted to pass that. Env console is essentially a way to run that command and inject all of your variables in there. And so the really great thing about it is, let's say you have 50 web app nodes up, right? And you change a variable, say the database password for those Django apps. I don't really like SSHing into 50 servers to restart that service. And env console actually does that for me, so I can just go right back to sleep.
So yeah, the choice there, it's tied into console, right? So you're running environments you're running your applications within an environment that has environment variables injected into it that come right from console. The killer feature here is that it's aware of console, which means if it changes in console, it changes in the environment that the app is running you can take action on that.
Automatic restart.
Right, so we actually, use systemd because it's all on CentOS. And systemd, we have the systemd's, I don't know what to call them anymore, startup scripts. I want to call them startup scripts. I know I'm not supposed to.
Upstart scripts, maybe?
No, it's systemd, not upstart.
I know, but I like to call it that.
Devops. We're just running env console and then a thing. And it's like magic. It just works. It's incredible.
One of the other awesome tools that we've been using a lot of, anybody use Consulate?
Consulate? One or two hands?
I don't even see a hand.
You guys got to get on this. If you're using console, you need env console and Consulate. These things are crazy.
So Consulate is a way to say, interact essentially with your console. So if you want to do a console set, Frosty equals amazing sparkly DevOps princess.
It's true.
You just do it with that command line. But more importantly than that, because the thing right now that we felt like we were missing was a backup, right? A kind of versioning of what was in console. And so we do that console KV backup, and then we just put that output up to S3, version it.
So yeah, it's a little bit ghetto, but it's a way for us to actually backing up snapshots of what's in console, which is pretty cool.
It's way more ghetto to lose all your data.
Truth. Preach it. So yeah, the console's the only thing that changes between our environments. We actually have a stage console and a prod console, and they're kept hygienically apart.
That's mostly true. User data is a little different too, but
it's fine. Well, is it hand wave that away?
It's close.
So all of this, right? All of this together, this HashiStack and all these kind of weird ideas about, how do we want to run things? What does this mean practically? Well, practically speaking, this is what we got. Atlas allows us to collaboratively review infra changes before they're applied, right? So
sorry about all those monk pull
requests.
requests.
Right, so that's like hypothesizing about the outcome if we want to torture the science model a little further. Packer creates templates so that our consistents are artifact over time. Mm-hmm. Terraform manages the actual application of those changes, right? Try to avoid human error. So that's a guarantee of consistency.
Try to avoid human error? I swear that was intentional.
I didn't want to put that in there. He made me put that. Control variables, right? So we want to guarantee the control variables. This allows us to do that. So when we make changes, we have a guarantee that we didn't make unintentional changes. As an aside, Packer lets you go multi-region, which is super dope.
Yeah. It's well, the great thing about Packer versus all of the hand-rolled scripts that I've been using since 2012, prior to meeting all of.
Bash.
Yes, it's. I've heard you use other words to describe my bash, Frosty.
I've used other words to describe your bash.
Indeed, but that can be pretty helpful and probably worth checking out.
And of course, we have monitoring tools, which I didn't put up on here, and that allows us to analyze the effects of the change, and then we can look at it and make a decision about whether it was a good change or not. So that's the sciencey model. So now we've talked a bit about what we were looking to do, the tools that we used to do it, kind of how does this wrap together? Practical story, perhaps,
so let's,
in 2 parts.
Yeah, let's think about what happened when we actually tried this. So sometime in late June, we went ahead and said, hey, yeah, Lon, Laura Thompson, we're ready to rock here.
Yeah.
And we went ahead and we did the flip.
We're going to do
now,
it.
We're looking at all of these logs from our old system, because that's the monitoring we had on our old system. But on our system, of course, we had all sorts of other Datadog metrics, some of which you've seen here. And as we flipped over the course of a couple hours, we realized we had been getting about 60 requests per second, because of Flash, hitting our crash reporting stats. However, when we made the flip, it suddenly went down to 30. What?
Suddenly we're getting half the traffic we were before.
And so obviously we flipped back.
Yeah.
I stayed up all night, had about 47 Red Bulls. And
I slept like a baby. It was amazing.
By the time everyone else, including Frosty and Lannon, had woken up, I was questioning whether or not Einstein was right. Maybe there's not really a fabric of reality I could count on.
Where all of our traffic is going.
How is this, how does DNS lose 50% of it? This can't possibly happen.
Turns out all the traffic was there. It's just that we used to be double counting all of it.
So for years, for years
we were double counting our traffic.
And we had no idea.
No idea.
And all of our monitoring that we set up on our systems during our flip wound up catching a bug that had existed in the old infrastructure for years. We didn't intend to do that.
But we did it.
So for that 24-hour period,
Dude, we gotta hurry up.
I was not happy. But now that I get to stand on stage and tell you the story about how much better this setup is than the old setup, now I'm happy that happened. But
hurry up.
Okay.
Migration Saga Part 2, right? So we had to switch it back because we thought we were losing half our traffic. Turns out we weren't. So we were at the Mozilla All Hands. This was in the mountains of British Columbia. It was a very beautiful milieu. Limited ops support, because all the ops were there drinking.
They had bottles of whiskey.
And nothing but hotel Wi-Fi as far as the eye could see.
And you can actually see our deployment whiskey right there.
That's our deployment whiskey. You can actually So what better time to migrate to AWS? You know, in the immortal words of Prodigy and Havoc, there ain't no such things as halfway ops, right? You got to do it. So we literally opened a bottle of the deployment scotch, hit play.
We were all super confident moving in.
It was super confident because we were like, we know the stack works, we know the tools work, we know the monitoring works.
We figured out this crazy data thing.
Amazing. We had high degrees of confidence. High degrees of confidence.
Ladies and gentlemen, this is our esteemed colleague, Rob Helmer, who was instrumental in this. He's not up on stage, but deserves a lot of credit. But he was ultimately not as confident as I've ever seen him.
Ultimately, it worked out amazing. We've been running in AWS ever since.
That sounds amazing.
And it's amazing. You know what?
Happy,
what a great way to end this talk. On a high note.
Oh,
right?
wait.
Oh, it's not all sunshine and rainbows. Oh, no. Okay, Terraform is great, but it's not magic. It can't see the future. It can't tell you when you're going to hit API thresholds, weird AWS problems, and friggin' hit all of them.
Yeah, if you do a Terraform plan, it doesn't check to see.
Sometimes it lies.
Can you have 30 nodes in this autoscaling group?
Right.
Because if the answer is no, you find out during the Terraform apply.
It's true. Now, the whole Packer process takes forever to run, and that kind of sucks. We have to manually load our console configs, and that can be kind of error prone. And you know, as long as we're on topic, long-running instances. Not really sure the best way to manage those in this infrastructure.
Right. I mean, so things like Puppet, right? Nagios, things like
Elasticsearch.
Right.
So tell me,
Jenkins, maybe.
JP, when you talk about long-running instances, I mean, how would you manage them? What's your default management technique?
Well, I think the default management technique that all of us have used is, I mean, I'm not saying it's ideal, Frosty, but this is really the way that I've gotten through it.
This is how we've done it in the past. So if actually we're going to be hanging around afterwards. If you've got strategies for dealing with long-running instances
I'd love to hear it.
That are better than this, please come talk to us.
Well,
you know, the fact of the matter is...
maybe a blanket or something to put over you while you cry.
It's mostly sunshine and rainbows. It's mostly sunshine and rainbows. We start with a multi-step, manual, error-prone, highly dangerous, no good, very bad deployment and management cycle. We ended up with the opposite of that, full of really cool buzzwords.
Oh, no. This doesn't have our newest link.
It doesn't.
Okay, this is the same link.
Of this. And you
but
can
it's
check it out.
HashiTalk 2015.
Yeah, so github.com/mozilla/hashiconf 2015.
HashiTalk
2015. Has like, we've got like a blog post there, and it's like code examples, and like everything is there. So
everything we've used, so.
Right, so, and this is the last slide. Because we started with a Shakespeare quote, I thought perhaps we'd end with one. Yeah? So, a warming peace this afternoon with it brings. The developers for happiness will deploy directly from head. Go hence to have more talk of these happy things. Some shall be pardoned, and some praised. For never was there a story of more joy than this of Mozilla and HashiCorp. Thank you very much, everybody.
Thank you.